Good morning to all. We are discussing the designing of deterministic finite automata. So, in case of deterministic finite automata, there is only a single transition that leads on a single input to the next state. Right. So, we are discussing some of the examples how to draw deterministic finite automata for the given example. So, let us start with some more example. Design a DFA to accept the string of A's and B ending with A, B, B over an input alphabet A, comma B. So as already we have discussed that. So first step we have to draw whatever may be the ask in the question. So it is asked in the question that design a DFA to accept the string of A's and B that ending with ABB means there may be any combination of string, but the string end with always three letters, that is this A, B and B. The string must end with A, B, B, right? So Q0, so very simple, Q0 on A go to Q1, Q1 on B go to Q2, Q2 on B go to Q3. Getting this point? So this is a simple step, means Q0, take four states, that is Q0, Q1, Q2, Q3. Input alphabets are nothing but your A, B, B. So we can mark this as nothing but end of the string. So here you will find here A, at the end of Q2 you will find here AB, and at the end of Q3 you will find here ABB. So whatever may be the strings are there, the strings are here, but ends are always marked with A and B, B. Right? Now we have to draw the remaining transitions for the remaining input or on each state. So here on Q0 A is clear. Now on B transition we have to mark B. Q1 B is completed here. Transition on input B is completed. Now if input A is given on Q1, where is to be transferred that Q1, then Q2 B is already done. Where to go for with the help of input A, and for Q2 also A and B inputs are there, then where to transfer these inputs. So here in case of step number 2 we draw like this. So Q0 on B, you can make a self loop that will not. So while drawing, as already we have discussed that while drawing the remaining input transition, we must not disturb this ABB sequence. So Q0 on B definitely go to itself, state itself. Now Q1 on A, so Q1 on A, the self loop is drawn here. Q1 on A, the self loop is drawn here. So that's why. So still we are not disturbing our sequence which we got, which we require. So that is nothing but A, B, B. So that's why self loop doesn't affect the sequence, that is the end string, that is A, B, B. Right? Then Q2. Okay, so the question is over for Q1 and Q0 and Q1 and Q1. Now come to Q2. Q2 on A. Now Q2 on A. Now you cannot draw a self loop here. If you draw self loop here, then what happens? The sequence become A, B, A, B. But this we don't want here. We want A, B, B. Right? So this is wrong here. So instead of this drawing here, so Q2 on A, you have to go to Q1 state. So transfer this input. So on Q2 input A, the state changes from Q2 to Q1. So I draw here A. Right? So what will be the string becomes? So string becomes A, B, B again. The string becomes A, B, B. Right? Okay. Now the Q2 is over. Now come to Q3. Now we want that the string must end with ABB. String must end with ABB. So here I get here ABB, because here ABB with Q0, Q1, Q2, I get here ABB. Now where to transfer the A input and B input of Q3 state? Where to transfer the input A and input B for the state Q3? So A can be transferred to Q1 and B can be transferred to Q0, so that our end of the string must not get disturbed here. End of the string must not get disturbed. So this is your final DFA that accepts the string of A's and B ending with A, B, B. Right? Okay. We'll go to the next example. Design a DFA to accept the set of strings of ones and zero not ending with 1010 over input alphabet 0, 1. Now the question asked is, we have to draw a DFA to accept the set of strings of ones and 0 that not ending with 1010, right? The string that does not end with 010, not end with, remember this point, So start drawing the DFA. Now take the 4 state Q0, Q1, Q2, Q3, our regular method. Q0 and first 0 go to Q1, Q0 and second input 1 symbol go to Q2, Q2 and third input symbol go to Q3 state. Mark Q3 as a final state, and this Q0 as a start state. Right now see here, remaining transitions. So we have to mark the remaining transitions of Q0, Q1, Q2 and Q3, and we have to also take care that the string not end. Now with this is the figure where we can write like this. This is nothing but the string that ends with 010, and we have to make the negation. Mean the string that does not end with 101. Get this point? So this DFA we have drawn. This DFA is for string ends with 010, ends with 010. Getting this point? And what is the question? Question is asked is the string that does not end with 010. Means the negation we have to take. We have to take the negation. Negation means what? How to take the negation? So just mark whatever maybe the states are there. So all the states mark as a final state. All the states, they are marked as a final state, and Q3 this is marked as a final state. So it remove the symbol of final state from the Q3. Getting this point or not? So Q3, which is marked as a final, remove its final status, and remaining all other states, those who are not the final state, mark them as a final state. Getting this point? So see here. So complementing above DFA means negation, or we have to complement the above DFA. So see here. So Q0 is marked as a final state. Q1 is also marked as a final state. Q2 is marked as a final state, and Q3. So this is by the mistake it is drawn here, but Q3 it is not marked as a final state. You have to remove this double circle here, right? So Q0, Q1 and Q2, they are marked as a final state here, and we have to draw the remaining transitions. So Q0 on 1 go to Q0 itself. Now Q1 on 0 go to Q0 itself, right? Then Q2 on 1 input, Q2 on 0 is already done here. Where to transfer the 1? So Q2 on 1 go to Q0 state. Q3. So Q3 you cannot mark here 0, 1. You cannot take the self loop because this is not your end state. This is not your final state. So 0, now 0 is transferred here on Q1 state, and 1 it is transferred here on Q0 state. So this is your final DFA. Where the strings does not end with 010. Getting this point or not? So first draw the DFA where the strings ends with 010. Now you have to complement. You have to take the complement of above DFA. Means mark all the state as a final, and make the final state as a non-final state, and draw the remaining transitions on the remaining input. Getting this point? So this is the example. Just go through it. Now we'll go to the next example. Example number 7. Design a DFA for a language that accepts all strings ending in 010 or 100 over input alphabet 0, 1. So very interesting. So here what we have to do here, you have to draw a DFA for a language that accepts all the strings end in 010. See here, ending in 010. Read the question carefully. The DFA, we have to draw the strings ending with 010 or 101. Sorry, 100. 100 or. So see here, or is given here. So or 101, right? So if the or is there, so definitely the transition diagram, it has 2 branches. If or comes there, or means it is nothing but your parallel execution, or means it is nothing but your parallel, and if it is and is there, then it is a serial transition diagram. Getting this point or not? If there is a or word comes here, or means either 101 or either 010 or either 100. Either this case is possible or this case is possible, 1 0 1. So Q0, I start drawing Q0 on 0 go to Q1, Q1 on 1 go to Q3, and Q3 on 0 go to Q4. Mark Q4 as a final state. Mark the Q4 as a final state. So this is a valid case. So this case is a valid case, right? Now go to the next input. So take the next input. So this may be, so there are strings, they may end with 0 1 0, or there are the strings that may end with 1 0 0. So again start with Q0. So as it is or, so there is a parallel execution, means this is possible or this is possible. So if the or is there, there must be two branches starting from the start state. Remember this point. There are two branches that are beginning from the start state. So Q0 on 1 go to Q2, Q2 on 0 go to Q5, and Q5 on 0 go to Q6. So this is your initial DFA. This is your initial DFA, means this is the DFA. This is the DFA that accepts the language that either ends with 0 1 0 or 1 0 0. That either ends with 0 1 0 1 0 or 1 0 0. Getting this point? Right now, remaining transition. As per our usual practice, we have to draw the remaining transitions. Right. So step number 2. So all other remaining transitions are drawn here. So then that becomes your final DFA. All the remaining transitions. So see it carefully. So first step is here. Now, so see Q0, both the inputs are complete. Both transitions on both inputs are there. That is 0 and 1. So there is no need. There is okay. Q0 is okay. Now come to Q1. So transition on 1 is completed. Now on 0. Suppose if I take the 0 as input. So where the 0 input will go? So I will take here 0, right? Because though taking 0 as a self loop, on Q1, it will not going to hamper your string. That will again you'll get here 0 1 0, no problem, right? Now go to Q3. Q3 on 0 go to Q4. Q3 on 0 go to Q4. Now from 1. So from 1, I cannot make here 1, because if I make here 1, so the string becomes 1 1 and 0. If I take a self loop on Q3, then the string becomes this one, this self loop 1 and 0. So this becomes 1 1 0. That we don't want. So instead of making it a self loop, so can I transfer it to Q1? I have to think here. So can I transfer it to Q1? No, you cannot transfer, because here 1 it becomes 1 1 and 0. If I transfer this Q3 to Q1, then also the strings becomes 1 1, this 1 1 and 0. So instead of transferring to Q1, I have to go to the Q0. So Q3. So here I'll make here as 1. Right. So the string becomes here 1 0 1 0. That is nothing but 1 0 1 0. The end is remain as it is. The end does not get disturbed here. The end of the string does not get disturbed. That is okay. Right. Then now okay. So Q3 is over. Now go to Q4. Now the inputs are 0 and 1. Both transitions are remaining. So for Q4, 0. So I can transfer 0 here. I can transfer 0 here for Q4, because transferring 0. So it becomes 0, this 1 and 0. The string remains, the end of the string remains as it is. Oh, no problem. And 1. So for 1, I have to transfer 1 to Q0 state. So here I'll transfer it here. That is nothing but 1. Right. Now this part is complete. This part is completely over. Now come to the next part. So on Q2, 0 transition is given. Q2, where to transfer 1? So transfer 1 can be self loop transfer. Getting it self loop does not going to affect your end of the string. That becomes your 1 0 0. See it carefully. Yeah? See it very carefully. Look it very carefully how I am drawing the DFA, because it is very important how to draw the deterministic finite automata. And definitely there is a question. There is a question on this particular DFA in the examination, right? Then okay, then go to Q5 state. Then Q5 state, transition on 0 is okay. Now on 1, where to transfer on 1? So on 1, I can transfer it here, right? So see here, it is correct, right? So 1 can be transferred here. Now Q5 is completed for both inputs. Now Q6, on 1 I can go to Q2, and on 0 I can go to Q0. So that you have to think it logically. You have to think it logically. You have to apply your mind, and you have to draw the DFA accordingly. Getting this point? So on Q6, I cannot make here self loop. If I make a self loop, definitely the end will get disturbed here. End will get disturbed. So instead of making self loop, I'll think here. So we have to transfer 1 and we have to transfer 0, and accordingly on that particular state, I will transfer. I will take the transition on 0 and 1 input from state Q6. Getting this point? Okay. Next example. See here, the same example, but the only the thing is that, see here, design a finite automata that reads the string defined over input alphabet. Sorry, this must be a comma b. Yeah? This must be a comma b, and accepts only those strings which end up in either a or bb. Means the same thing. Means in the previous example we have discussed, if there is or, there must be two branches starting from the current state. So this is starting from the start state. So this is the start state. So there must be one branch going to this particular string, and another branch must go to the second string. So first I'll draw here Q0 on A go to Q1, Q1 on A go to Q2, Q0 on B go to Q3, and Q3 on B go to Q4. That is nothing but AA and BB. This first step is clear. So Q1, that is nothing but the start state. Q0 is the start state. Q1, A of the sequence A is seen here, means here I can write here A, and Q2 double A, that is sequence of A is seen here. So this is nothing but here AA. Now Q0 on B, Q3 is nothing but B of sequence BB is seen here. So if I get here if I complete Q3, so I will find here in that is nothing but string B, and if I completely go to Q4, I will find here the string is BB. Right? So this is the case. Now what we have to do here? So only those strings that end up with A and BB. So there must be end like this double A or double B. So that's why or is there. That's why the two branches are drawn here, A and B. Now what is the next step? As you know that for the next step we have to draw all remaining transitions on the remaining input. So Q1 on B, we have to transfer Q1 on B. On Q2 on A and B, we have to transfer A and B. Q3 on A, because B is done here, A is remaining, and Q4 on A input and B input, we have to transfer the both the transitions that we have to see. So here in next step, the diagram is drawn here, right? So the next step is here. So this A is there, Q1 on B. So instead of, if I make here B, so this becomes wrong because the string becomes your BA. So BA we don't want here BA, we want AA, right? So B transition I will transfer it to Q3 state. So this is nothing but the B, right? Now from Q3 the input A go to Q1. I will not make as a self loop here. If I make a self loop, then the string becomes AB. So Q3 on A go to Q1 itself, right? Now come to Q2 state. On A, you take a self loop, because though you take a self loop, whatever may be the string, you will get always end with double A. But you cannot have B here. You cannot take B here. If you take B here, it will going to disturb your end sequence double A. So B must be transferred to Q3 state. So you take B here. So this becomes your B, right? That is also not going to disturb your BB sequence. Right now this Q2 is over. Now come to the final, the remaining state, that is nothing but the Q4 on B. You can take the self loop for B, and A you can go to Q1 state. So remaining transitions, you have to see all the possible conditions while drawing the remaining transition. The sequence, the end sequence, whatever may be the ask in the question, the substring must not get disturbed. Accordingly I have to transfer or take the transitions on the remaining input symbols. Getting this point? Next example, we'll see another example. Design a FA which accepts even number of zeros and even number of ones over input alphabet 0, 1. So even number of, so we have to design a finite automata. We have to design a finite automata which accepts even number of zeros and even number of ones. Means there must be two zeros and two one, 2 0 2 1, or either 4 0 and 4 1. Right. So if there is a 3 0 and if there is a 2 1, this string must not get accepted by the finite automata. So first we'll identify the states. So Q0 is the start state and end state for every start state and end state for even number of zeros and even number of ones. Identify, or we have marked Q0 state as the start and end for even number of 0 and even number of 1. Q1. Now Q1 is marked for even number of zeros and odd number of ones. Q2 it is marked for odd number of zeros and even number of ones. And Q3 state it is marked for odd number of zeros and odd number of ones. So what is the meaning of this? The meaning of this is that, so if in the string suppose 0 0, so if it is a 0 1, that is nothing but odd number of 0 and odd number of 1. If it is there, then you have to go to the Q3 state. Getting this point? Then if suppose if this is the string is there, so that is nothing but even number of 0 and odd number of 1. Right? Even number of 0 means 2 0 and 1 1. So even number of 0 and odd number of 1 means you go to the Q1 state. Right? If the sequence is like this 0 1 1 means odd number of 0 and even number of 1, that is even number of 1, then you have to go to Q2 state. You have to go to Q2 state. Right? So this is the way. And Q0 state, that is nothing but your even number of zeros and even, so this is your final answer. So Q1 is nothing but your final state, or here Q0 state gives us the final DFA which accepts even number of zeros and even number of 1. Remember this Q0, we have defined the Q0 state like this. Q0, when reaching to the Q0 state, we will get our final answer, that is even number of zeros and even number of ones. Right? And Q1 even number of 0 but odd number of 1. Q2 odd number of 0 and even number of 1, and Q3 both odd number of zeros and odd number of ones. Because whatever may be the string, we don't know which will be the next input, or which will be the next input, and how many number of zeros and how many number of ones will be there in the coming input strings. We don't know this thing. That's why we have to identify the states like this: Q0, Q1, Q2 and Q3. So just start drawing this. So first draw the transition table. So Q0 on 0 go to Q1 state, Q0 on 1 go to, so depending upon these transitions, depending upon the states, we have drawn the transition table here. We have drawn the transition table. So Q0 on 0 go to Q1, Q0 on 1 input go to Q3. Right? Q1 on 0 go to Q0, Q1 state, current state is Q1 and input is 1, go to Q2 state. Current state is Q2, the input is 0, go to Q3 state. Current state is Q2, input is 1, go to Q1 state. Current state is Q3, input is 0, go to Q2. Current state is Q3, input is 1, go to Q0 state. Right? And the final DFA drawn like this. So Q0 is your final start as well as final state. Remember this thing. Q0 it is marked as the start state as well as the final state. Why? Because here we'll get here even number of zeros and even number of 1 after reaching to the Q0 state. Q1 state is nothing but even number of 0 but odd number of ones. Q2 is nothing but your odd number of zeros and even number of ones. And Q3 is nothing but odd number of zeros and odd number of ones. Right? So this is the way Q0, Q1, Q2, Q3, where we first identify the steps, and the transitions are drawn based upon this transition table. We have drawn the transition graph. Q0 on 0 go to Q1, Q0 on 0 go to Q1, Q0 on 1 go to Q3, Q0 on 1 go to Q3 here. Right? Now Q1 on 0 go to Q0, Q1 on 1, Q1 on 1 go to Q1 on 0 go to Q0, and Q1 on 1 go to Q2 state. So like this way, this is the DFA drawn for finding out, or to draw the DFA which accepts the even number of zeros and even number of ones. Getting this point? Okay. We'll go to the next example. Okay, so see here the interesting example. Design a finite automata to check whether a given decimal number is divisible by 3. So decimal number means we have to take the input set in C, define the input, that is nothing but your sigma equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is nothing but your input alphabet. This is nothing but your input, right? And possible reminders. And what we have to check here, we have to check whether these number, whether this input alphabet, they are divided, these are divisible by 3 or not. So if you try to divide 0, 1, 2, 3 up to 9 numbers by 3, we'll get three possible reminders. We'll get three possible reminder 0, reminder 1, and reminder 2. If we divide 0 by 3, we'll get reminder 0. If we divide 3 by 3, if we divide 6 by 3 and 9 by 3, so this group we have combined. So all these four inputs, they form a group of reminder 0 group, and we marked it as a state number Q0. Are you getting or not? So we have to design a finite automata to check whether the given decimal number is divisible by 3. So given decimal number means there are possibility to 0 to 9. These are the decimal numbers, 9 numbers, and we have to find out whether this is divisible by 3 or not. So there are three reminders are possible: reminder 0, reminder 1, and reminder 2. So these are nothing but our states. We have identified these are nothing but our states: 0 reminder states, 1 reminder state, and 2 reminder states. Now for 0 reminder state means for Q0 state, which are the inputs? Inputs are 0, 3, 6, and 9. Getting this point? Now for 1 reminder state means the reminder 1 group, reminder state is Q1. So which are the inputs? So which inputs you shall give here so that you will get 1 as a reminder? So input are 1, 4, and 7. Input are 1, 4, and 7. If you give the input as a 4 and try to divide by 3, you will get a reminder equal to 1. If you take input as a 7 and try to divide by 3, you will again get a reminder as a 1. So this is nothing but input group, and this is nothing but the state Q1, where it is nothing but you will get the reminder as a equal to 1, right? Now the reminder 1, reminder 2, this is reminder 2 group. Reminder 2 group is nothing but your Q2. So input is 2, 5, 8. So try to divide 5 by 3, 8 by 3, and 2 by 3. Always you will get reminder is equal to 2. So that's why it is marked as a state Q2. That's why it is marked as a state Q2. So reminder 0 group Q0, reminder 1 group state is Q1, reminder 2 group state marked as a Q2, right? Q0 will be the final state as it is reminder 0 state. What we have to find out here? We have to find the decimal numbers which are divisible by 3, exactly divisible by 3. So means we have how many inputs are available? So anytime, suppose anytime user may input, say for example 3, so our DFA must recognize yes, the 3 is divisible by 3 or no, means we will get only 2, yes or no answer. If a user enters 3, definitely it will go to the final state, that is nothing but your Q0 state, that is nothing but your 0 reminder group. But if the user input is equal to 4, then it will go to Q1 state, and Q1 is not your final state, telling that the number is not divisible by 3. Getting my point or not? We have to find out the number, decimal number. Suppose user input some number, we have to check whether that decimal number is divisible by 3 or not. And for this thing, we have to draw the DFA, deterministic finite automata. So we have identified the input set. First input set is identified, and the state Q0, Q1, Q2. These three states are identified: 0 input state, 0 reminder state, 1 reminder state, and 2 reminder state, right? The next step in this particular problem is step number 2. See, draw the transition table. Draw the transition table. So this is nothing but your states. These are nothing but your state Q0, Q1, and Q2. 0 reminder state, 1 reminder state, and 2 reminder state. Getting this point? And Q0 is nothing but your final state, as well as it is marked as a start state. Final as well as the start state. And see here, this is the first input set 0, 3, 0, 3, 6, 9. This is the first input set. 1, 4, 7, the another input set, and 2, 5, 8. This is the third input set. This is the third input set which is given as a input to the DFA, right? Now you are at Q0, and input is 0, 3, 6, 9. Input is 0, 6, 3, 6, 9. Definitely the next state is q0 itself. Why? Because you are trying to divide 3, so you are remaining at state q3. You are trying to divide 6 by 3, you are at q0 state. 9 by 3, you are at q0 state. Getting this point? Now you are at state q0 and input are 147. Input are 147. Definitely it will. So try to divide 4 by 3. So remainder is 1. And which is the remainder 1 state? Remainder 1 state is nothing but your q1 state. Getting my point or not? Means you are at state q0, input are 147, and if you try to divide 4 by 3, so you are getting remainder as 1, and 1 is nothing but your which state? 1 is nothing but your which remainder state? 1 is from your q1 in a remainder state. That is nothing but q1 state, right? 5258. You are at q0 and input applied is 2, 5. Either it is a 2 or either it is a 5 or either it is a 8. Suppose if it is 8 and input is 8, you are at q0 state, and if I try to divide it by 3, so I will get a remainder is equal to 2. Remainder is equal to 2. So remainder 2 is nothing but which state? Remainder 2 is nothing but my q2 state. Getting this point? How to draw the transition table? First, transition table is drawn, and then you can go to the transition diagram. Then you can go to the transition diagram for the DFA, which can recognize the number is divisible by 3. Yes or no, we are getting answer in the form of yes or no, right? We are not getting any sort of any kind of output here, right? Q1, again come to Q1, we are at Q1 and input is, say for example 0369. What is the Q1? Q1 state itself, it is a one remainder state. It is a one remainder state, right? So though 3 is completely divisible by 3, 3 is completely divisible by 3, but state itself, it is a one remainder state. That's why Q1 is nothing but the next state. Getting my point or not? Though we 6 is completely divisible by 3, 0. So 0 plus 1, 0 plus 1, one remainder state is nothing but your Q1. So the next state Q1 on this 0369 go to Q1 itself, right? Now you are at Q1 means one remainder state, and the next input is, say for example 1, 4 and 7. 1, 4 and 7, right? So what we can do here, so 1, 4 divided by 3, 4 divided by 3 you will get here 1, 4 divided by 3, remainder you are getting here 1, and the already you are in a one remainder state, so 1 plus 1, that is nothing but 2, so combined remainder you are taking here 2, so that's why the remainder state is nothing but your Q2. The next state is nothing but your Q2 state. Getting this point? So you are at now Q1, inputs are 258, input are 258, so 2 divided by 3, so you will get here 2 as a reminder and 1 is from input, so 1 plus 2 is equal to 3, so definitely 1 plus 2 equal to 3, so 3 is nothing but your which state? 3 is nothing but my Q0 state. 3 is nothing but the Q0 state. Getting this point? Now come to Q2, Q2 at 0, so 3 by 3, so 3 by 3 you will get here 0, but 2 remainder is already there because Q2 is the 2 remainder state. That's why Q2 on 0 go to Q2 itself. The similar calculation, Q2 on 1 go to Q0 and Q2 on 2 go to Q1 itself. Because what happened? So Q2 on by 2 by 3, for example 2 by 3 you are getting remainder is equal to 2, right? 2 plus 2, this 2 plus this 2, that is equal to 4, and 4 by 3 is nothing but you are getting remainder as a 1, and remainder 1 is nothing but your Q1 state. Remainder 1 is nothing but your Q1 state. So this transition table is important to draw first, and then up from this transition table it is very simple to draw the transition diagram. See here, this is the first. So Q0, so Q0 is nothing but 0 remainder state, so all 0, 3, 6, 9 self loop. Q1 is nothing but your one remainder state, 0, 3, 6, 9, so input is 147 and so input is 0, 3, 6, 9, so 0, 3, 6, 9 and input and state is Q1, so next state is again Q1 here. Now input is 0, 3, 6, 9, current state is Q2, so it will go to Q2 state, right? So it will go to self loop is there, and remaining transition, these are the remaining transitions. So these are the remaining transitions, draw in the next step of the transition diagram. So see here, right? So these are the remaining steps in the transition diagram, right? Okay, we'll go to the next. Okay, so another interesting example to draw a DFA. that read the string. See, read the question carefully. That reads the string made up of letters in the word CHARIOT, CHARIOT, and recognize those strings that contain the word cat as a substring, as a substring. So very simple. So input set is given, that is nothing but your CHARIOT. This is your input string. And what substring you want here? You want this CAT as a substring. Just start drawing with the straight away. Draw the CAT. Q0 on C go to Q1, Q1 on A go to Q2, Q2 on T go to Q3. So you will get here CAT as a substring, right? And what is the steps 2? You know that in steps 2, whatever may be the remaining transitions. So inputs are, how many inputs are there? So for Q0, how many inputs are there? So C is already done. You have to draw for HARIOT, right? For Q0. For Q1, input A is completed. For Q1, A is completed. For CHRIOT, where to transfer CHRIOT excluding A, because A is already done here. So remaining input transitions you have to draw in the second step. So how it is drawn? So just see here. Okay, this is the final DFA. This is the final DFA. This is the final DFA for the substring CAT from the given string CHARIOT. Input string is given to you. Input string is given to you, and you are asked to draw a DFA for the substring CAT. So Q0 on C is drawn here. So remaining input, that is HARIOT, you take here self loop. Now Q1 on C go to self loop, and remaining, that is excluding C and A, all other inputs they go to Q0 state, right? Q2 T is over. Now take C to this Q1, because here you will get here CAT, and excluding C and T, all other inputs must transfer to Q0 state, right? And final, your Q3 is the final state. Then all inputs you can have at final state, because taking any input at the final state does not going to affect your CAT as a substring. So though it is the say, for example, H, so it becomes your CAT H, but still this CAT is a substring, remains as it is without getting affected, right? So this is the case. So again, a simple one, design a DFA for a set of strings containing either substring triple A or triple B. So you know that for, if it is a OR, so there must be branches from starting from Q0 A, then Q0 on B, so Q0 on B, Q4 Q4 B, Q5 B, that go to Q3, and triple A, Q1 Q2 and Q3 finally, and the remaining transitions are drawn. Whatever may be the rest of the transitions, they are drawn in the final DFA diagram. So this is nothing but your final DFA for the strings containing either substrings triple A or triple B, right? Okay, so in this particular session, what we have learned deterministic finite automata along with the DFA definition, how to draw the DFA for various different kinds of problem, what is the importance, what is the significance of the start state, final state, and how to draw the transitions, all the transitions on given states, that already we have discussed with the various different types of examples, right? And the course outcome attainments, again, they construct the finite state machine to solve the problem in computing. And the reference book, these are the books which we have to refer for this. Okay, so let us stop here for the today's lecture.